Randomness is one of the most important pillars to support the statistic and probability tempo. Randomness is unpredictable. In common parlance, randomness is the apparent lack of a pattern or predictability in events. Please remember, randomness is unpredictable, but it's not equal to uncertainty. Let's say Team A has a 60% chance to win the game. That percentage is a certain number, although you can't tell whether they will win or lose next time. We can consider randomness as that we know all possibilities, but the only thing we do know is which one will happen next. Flipping a coin. You do know whether it will show head or tail, but it must be one of them. Shuffle play music. Although you can't predict which song will play next, it must be one on your playlist. On the other hand, uncertainty is we have no idea what can happen next. For example, the black swan theory. Something that comes as a total surprise. By the way, all swans in New Zealand are black. Here is a picture I took last week. When studying a certain field, you can apply two strategies, bottom-up and top-down. Bottom-up strategy, we will build up the concepts fundamental to more advanced. This approach is often more preferable when we learn things in school. The advantage is that we can at all times rely on previous learning concepts. However, most of the times, we soon find a lot of concepts that are not particularly interesting or anti-tuitional. So, as you know, the lack of motivation means that most of them are quickly forgotten. Top-down is digging down from a particular goal to more basic requirements. This goal-driven learning strategy lets us know at all times that's why we need to work on a particular concept, and there is a clear path of required knowledge. The shortage of this strategy is that the knowledge is built on potentially shaky foundations. The path to our destination becomes foggy and we can easily be lost. In my video, the question asked tied together with the topic, so you won't have to worry about bottom-up or top-down. But I believe you may with a real-world question when watching this video. In that case, I hope this video can help you get the concept in an efficient manner, so you can decide whether to go deep or search somewhere else. Back to this video's hero, randomness. Technically speaking, it is impossible to generate a random number on a computer. It has to be based on some sort of seed. The problem is that the seed isn't truly random. Therefore, there is nothing random about a computer. Randomness can only be simulated by a computer. At this time, you can consider quantum fluctuation is the only true randomness. Be aware here, we human beings not good at recognizing randomness, and we are terrible to generate random things too. When Apple first introduced Shuffle, which will randomly play the music you have, they got a lot of complaints like, I don't feel my music randomly played. You know, I have tons of music in my iPod. There's a dozen I can hear day in day out, and others I won't hear for weeks. Or, when song plays 3 times in a row, how can you call that random? At the time, Apple introduced a Smart Shuffle feature, which essentially lets you drag a slider of how random your shuffles would be. I remember Steve Jobs joked about this when introducing the iPod Shuffle. Some scientists believe there is no randomness at all. You can find the causation chain of every event. Like when you flipping a coin, your hand movement contributes to a large portion of whether it will land tail or head. Your hand moves that way because the signal generated from the brain, and the brain generates that signal because the surroundings and even the food you just ate. This chain go on and on, but I suppose you get the idea. there's no random at all. Why we see randomness is we can't gather all the information to analyze the causation chain. But I want to argue here that quantum fluctuation is true randomness, at least for now. So who is right? We will see. How to take advantage of randomness? Let's see an example. Some genetically modified crops have insect-resistant genes. However, insects will immune to it really soon, since the majority died after eating the crop. Only those who, because of gene mutation, have the anti-insect resistant genes survive. How to deal with it? Simple. We just put some non-genetically modified crops in this field. By doing that, we remove the filter of insect gene mutation. Let the randomness back to gene mutation so the crops can resist insect for a much longer time. I'm always here at your service. Can't wait to find how to measure and quantify the randomness. See you in the next one.